So an exterior angle is any angle on the outside of a triangle that forms a linear pair with the adjacent interior angle. And a remote interior angle is the angles on the inside of the triangle that are on the other side of it. So if you think about your remote control, you use remote control so that you can control things from far away. These angles are far away from the exterior angle. So if we look at the picture, here's your exterior angle. It's on the outside, so the remote angles are on the other side of the triangle. The measure of the exterior angle is equal to the sum of the measures of the remote interior angles. So here's how that works. If I have a triangle and my remote interior angles are A and B and my outside angle is C, C is equal to A plus B. If you think about it, it makes sense. A straight line adds up to 180 and a triangle adds up to 180. So if this plus this equals 180, then this plus this equals 180, this has to equal both of those. Does that make sense? So C is equal to A plus B. And then if the two angles of one triangle, so the green and the blue, are congruent to the two angles of the other, green and blue, then the third angles have to be also congruent. So x would equal 69 degrees. When you see one like this, the outside angle is the two inside angles added together. So 9 is going to be 5 plus 2. But they're giving us 9, and they're giving us 2. So 5 is going to be angle 9 minus angle 2. So 112 minus 47, which is so 65. Number 1 is going to be 5 plus 8. So angle 8 is angle 1 minus angle 5. So 103 minus 59 is 44. I'm going to switch to D. D is a little bit different because of this statement right here. Angle 2 is 22 more than angle 8. So we're going to be throwing some algebra in there. So if we look at this, here's angle 6, I have angle 2, and I have angle 8. Angle 2 is equal to 22 plus angle 8. Angle 6 is equal to angle 2 plus angle 8. So if I put some variable in here for 8, we'll just call angle 8x. I have 124 is equal to angle 2, which is 22 plus x, plus angle 8, which is also x. So I have, if I put those together, 2x plus 22 will equal to 124. And then I solve from there. Minus 22, so 2x is equal to 102. Divide by 2, so x is 51. A polygon is a union of segments that meet at the endpoint such that at most 2 segments meet at one point and each segment meets exactly 2 other segments. Okay, so what that means is we have a polygon. Something like that. You can have something like this. It could be anything. Mostly you're used to squares, rectangles, triangles, things like that. These are polygons. Not polygons. Okay, you can't have meeting in the middle. Okay, so no lines can cross each other. You can't have lines that just go off into nowhere that don't meet up with anything. You can't some unclosed figure. Everything has to be, so as you can see, each one of these, you have two lines connecting, two lines connecting, two lines connecting, two lines connecting. And always at the end, the vertices. Here I have 1, 2, 3. That can't happen. I can't have more than two lines connecting. This would not be a polygon. Okay. Also, it's segments, so you can't have any curves. So a half circle would not be a polygon. A circle is not a polygon. Some sort of flag shaped thing is not a polygon. No curves. So far, okay? Okay. A convex polygon has all of its diagonals on the interior. Okay, diagonals we'll talk about in a second. They go from one corner to another, but not from this corner to this corner. It's not a side, so it would be like this corner to this corner, or this corner to that corner. So a convex polygon, if I look at a convex polygon and I create all the possible diagonals, so I can go across to here and here, or I can go from here to here, or I can go from here to there. They're all on the inside. None of them cross outside of the polygon. So this would be convex. Non-convex are also called concave. And if you look at the convex ones, and we talk about the diagonals, see how all of these are on the inside? Okay, that's a creepy thing again. It's not, I didn't actually put that picture in there, so all the diagonals as we go through are going to be on the inside. Okay? When you get into concave, diagonals go to non-adjacent vertices. So this diagonal is on the outside. This diagonal crosses to an outside. So we do have some, in this case, on the inside, but we have some on the outside as well. And if you're convex, you can't have any on the outside. And they can't cross the out, like they can't go outside the shape. So like the convex ones are kind of more round, bubbly. And the concave ones look like somebody caved them in, like a side will dent in. If that helps. We have equilateral and equiangular. An equilateral polygon has all congruent sides, so all sides are the same length. Think about a square. Okay. An equiangular polygon has all angles of the same measure. An equilateral triangle, we call it an equilateral triangle, but it's equilateral and equiangular. It's both, yeah. Because all the angles in an equilateral triangle are 60.
So the only way to identify if it's equilateral
is to look at the angles.
is to see if the sides are.
Well, no, hold on, let me think about that for a second. No, you can be equiangular and not have the sides the same. Think a rectangle.
Well, that's the thing, is if it's equiangular and all the sides are the same, it's equilateral.
Yes. Well, if it's both, it's called regular.
Oh, okay.
So equiangular, if you think about a rectangle, all four angles are 90 degrees, but all four sides aren't the same length. So you can be equilateral only. You can be equiangular only. A rhombus has the same length, same side lengths, but doesn't have the same angles. And then a rectangle has all the same angles, but not the same side lengths. If you're both, if you have equal angles and equal sides, you're regular. So sides and angles are all the same. And then the diagonal, we talked about that. That's a segment that connects two non-consecutive vertices. Those see the previous page for that. Or I'll just draw another one. Ta-da. Diagonals. If you have a convex polygon, so it has to be, you know, the bubbly one, not the caved in one. If you want to figure out how much degrees the angles are, so you know how a triangle is 180. Well, we can figure out the degrees of any number of sided figure using this formula right here. N is the number of sides, so we take 180 times n minus 2. So let's say we do an octagon. So we'd have 8 sides. It would be 180 times 8 minus 2. So 180 times 6, which is some number. Hold on. 1080. So an octagon has 1080 degrees in it. Yeah, if it's a regular octagon, it would have 8 angles, so each angle would be 1080 divided by 8. If it was irregular, we'd have to know some of the angles to be able to find the other ones. Okay, if you take the exterior angles, so if we have a shape like this, the exterior angles are all of the ones that are extending outward like this. They have to go in the same direction, kind of like spokes of a wheel. If you add all of these up, they would add up to 360. And it doesn't matter what shape it is. If all of the exterior angles are going in the same direction like this, they will always add up to 360. Yeah, remember how I said this is kind of like spokes of a wheel? If we took all these, we'd make a circle. So that's why it adds up to 360, because a circle is 360 degrees. Now, if we have a regular polygon, which means that the sides and angles are the same length, we can figure out how much each individual angle is by doing this. So here's, if we did 8 sides again, we have our 180 times 8 minus 2, and then we divide that by the number of sides. So that's 1080 divided by 8, so each angle would be 135 degrees. Only because we have a regular polygon. And then if we have a regular polygon here, and we want to figure out the exterior angles, if we have regular, again, they're the same, so if we have a regular octagon, we would take that 360 and we would divide it by 8. So our external angles in an octagon are all 45 degrees. So the interior ones are all 135 and the exterior ones are all 45. With this n-gon thing, this is if like you don't know the name. So if you had like a 23-sided figure, you'd call it a 23-gon. And you can do that with any number of sides. Like if you don't know the name, you can say the number gon. So if you didn't know 11 was hendecagon, you could just say 11-gon. Find the sum of the measures of the interior angles. So sum, that's the 180 times n minus 2. So I want to know one for 11 sides. So 180 times 9. So 1620. Okay, here we're going to go backwards. We know the total of the angles and we want to find the number of sides. So 1260 is equal to 180 times n minus 2. So we just need to figure out what n is, so we divide both sides by 180. So we have 7 is n minus 2, so add 2 to that. So we know that if your angles are 1260, you have 9 sides. here we're going to find each interior. That's where we divide by the number of sides. So it's a pentagon, so that's 5 sides. So 180 times 5 minus 2 divided by 5. So that's 180 times 3 divided by 5. And 180 times 3 is 540. And divide that by 5, and each one is 108 degrees.